Electrochemistry class. Today I am introducing a new chapter, Reactivity series and Electrochemistry. Are you ready? Okay. So we are discussing about reactivity series of metals. Let's start now. Have you noticed these pictures? Certain instances of using electricity and some sources of electricity are shown in these pictures. Aren't they? Yes. We use different kinds of batteries to work electronic equipments. Here, chemical energy is converted to electrical energy and vice versa. You may have noticed different metals used in a cell, but maybe its reason. Let's find it. You have already observed the pictures like rusting of iron and the formation of verdigris on copper. Are all metals like this? No. While some metals engage in chemical reactions vigorously and certain metals react sluggishly in the same reaction. Today, let us find out the difference in reactivity of metals and try to examine how they can be utilized in different cells. So, let's start this session with a video. Here we have a video about reaction of metals with water. Some metals are here: aluminium, copper, iron, lead, magnesium, potassium and sodium. Put some pieces of these metals separately in beakers, half filled with the cold water. Which metal reacted with cold water? Yes, magnesium reacted with the cold water. Did any metal catch fire in water? Yes, sodium. Metal like sodium react vigorously with the water and catch fire. Does any metal starting floating after some time? Yes. Calcium. Calcium start floating after some time. So the observation here, metals like aluminium, ferrum and zinc do not react either with cold or hot water, but they react with steam. Metals like potassium and sodium react vigorously with cold water. Sodium reacts with water to evolve hydrogen, which immediately catches fire, producing a lot of heat. So it is an example of exothermic reaction. The potassium reacted with the water to form the equation. 2K plus 2H2 gives 2KOH plus H2 plus heat. Sodium reacted with the water to form the equation. 2Na plus 2H2 gives 2NaOH plus H2 plus heat. Calcium reacted with the water less vigorously. Hence, the heat evolved is not sufficient for hydrogen to catch fire. Hence, instead calcium start floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Calcium reacted with the water to form the equation. Ca plus 2H2 gives CaOH twice plus H2. Hydrogen gas is evolved. Put the metals that did not react with the cold water in beakers half filled with the hot water. Note your observation. Here we can see the decreasing order of reactivity series of these metals like aluminium, copper, iron, lead, magnesium. So the most reactive metal is magnesium, then aluminium, ferrum, lead and copper. Magnesium reacts with hot water to form magnesium hydroxide and hydrogen. Magnesium also starts floating since the bubbles of hydrogen gas stick to its surface. Write the equation for the above reaction. So Let's observe it. Magnesium Mg plus 2H2O gives MgOH twice plus H2. For the metals that not react with the hot water, arrange the apparatus as shown over here and observe the reaction with steam. Metals like aluminium, iron and zinc do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. 2Al plus 3H2O gives Al2O3 plus 3H2. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Metals like gold, silver and copper do not react with water at all. About reaction of metals with air. Let us explain this with the help of an activity. Take a magnesium ribbon and burn it. Collect the ashes formed and dissolve them in water. Test the resultant solution with both red and blue litmus paper. Is the product formed on burning magnesium acidic or basic? We observe that the red litmus turns blue, but no change in blue litmus. Thus metals react with the oxygen to give metal oxide. On dissolving it, produces metal hydroxide. So it is basic in nature. So here magnesium reacted with the oxygen to form magnesium oxide. Mg plus O2 gives 2MgO. This magnesium oxide reacted with the water to form magnesium hydroxide. MgO plus H2 gives MgOH twice. Let's see a video of sodium. This is a sodium metal. It is not like your normal metal. It has a few weird qualities. Firstly, it has to be stored underneath oil, or it will react with air and moisture in that air. You can actually squish it just by poking your finger into it. Sodium being so soft means you can actually cut it with a knife, just like butter. The freshly cut surface of sodium metal will have a shiny appearance. Its shiny fades after some time. This is due to the conversion of sodium into its compounds reacting with the oxygen, moisture and carbon dioxide in the atmosphere. The third activity is reaction of metals with a dilute hydrochloric acid. So here see copper. Copper is very unreactive metal, and there will be no reaction between it and HCl, no matter what the temperature or the concentration. Iron have very slight reaction. Iron is slightly more reactive than copper, but at room temperature with a dilute acid, there is still no reaction. However, if you increase the concentration or heat the solution, it will react. Zinc have slow reaction. Zinc is more reactive still. If you look in carefully, you will see small bubbles of hydrogen rising from the pieces of zinc metal. This is hydrogen gas at room temperature. In dilute acid, the reaction is still slow, but it does proceed. Then magnesium. Magnesium has faster reaction. Magnesium is the most reactive of all metals. Here, and you can see it begins an immediate and vigorous reaction with the dilute acid, producing hydrogen gas and a significant amount of heat. You can see the condensation on the inside of test tube. Within a very short period of time, the magnesium has completely dissolved to abuse magnesium chloride and the hydrogen gas. So we have already observed videos from 3 activities. They are reaction of metals with water, reaction of metals with air, and reaction of metals with dilute hydrochloric acid. So the observation from these 3 activities are recorded here. The first activity is reaction of metal with water. What did you observe from the video? Yes, metals like sodium and potassium react vigorously with cold water, and its equation is written here. And the next metal is calcium react with water less vigorously. Hence the heat evolved is not sufficient for hydrogen to catch fire. Then magnesium, we observe that magnesium react with the hot water to form magnesium hydroxide. The other metals like aluminium, iron and zinc do not react either with cold or hot water, but they react with the steam to form metal oxide and hydrogen. And we also observe that metals like gold, silver and copper do not react with water at all. So the second activity is that reaction of metals with air. From the observation, we already observed that magnesium rubber react with oxygen to give metal oxide, and it ashes on dissolving produces metal hydroxide. So it is basic in nature. Okay. From the third video, we observed that from the video of sodium metal, the freshly cut surface of sodium metal will have a shiny appearance. Its shine fades after some time. Why? This is due to the conversion of sodium into its compounds by reacting with the oxygen, moisture and carbon dioxide in the atmosphere. Then the third activity is reaction of metals with the dilute hydrochloric acid. From the videos we observe that copper is very unreactive metal, and there will be no reaction between it and HCl no matter what the temperature or concentration. Then iron is slightly more reactive than copper, but at room temperature with a dilute acid there is still no reaction. However, if you increase the concentration or heat the solution, it will react. Zinc. Zinc is more reactive. Still, if you look carefully, you will see small bubbles of hydrogen rising from the pieces of zinc metal. This is hydrogen gas at room temperature. In dilute acid, the reaction is still slow, but it does proceed. Then we observe that magnesium is very reactive metal. Hydrogen is rapidly evolved, and you can see condensation of the sides of the test tube from the heat of reaction. So, from these three experiments, we understood that the metals that involved in the reactions, they presents what kind of peculiarity they have. The metals which shows differ in their reactivity. Yes, we can observe that metals differ in their reactivity. So, based on this observation, arranging the metals in the decreasing order of their reactivity is shown in this picture. So, the reactivity series of these metals are represented in these pictures. So, simply we can say what the series obtained by arranging metals in the decreasing order of their reactivity is known as reactivity series. So, reactivity series of metals are represented here. The series obtained by arranging metals in the decreasing order of their reactivity is known as reactivity series of metals. From this picture, we can identify that metals from lead to potassium react with dilute HCl and displace hydrogen. And the metals like copper, silver, gold do not displace hydrogen from dilute HCl. So finally, thank you all for watching. I hope all of you understood this session.